In this film, we shall cover the overhaul and maintenance of an in-service Alfa Laval WHPX type separator. Part 1 details the bowl maintenance procedures. Dismantling the bowl assembly. Before commencing any operation, the following safety procedures must be observed. Carry out the manufacturer's desludge program, fill the bowl with water and maintain during rundown. Using the brake, bring the machine to a standstill. Close all valves and cocks. And ensure that the machinery is stationary and isolate it from the power source. Check that the lifting equipment will be working within its safety limits. And drain the sump before removing the revolution counter plate assembly. It should be noted that the sump oil requires changing after every 1,000 hours of use. Having removed the counter plate, it is possible to check the worm and gear assembly for wear, spalling, scuffing or pitting. If any wear or damage is found, replacement should be considered. Before continuing, the counter plate must be loosely replaced to avoid dirt entering the gear housing. First, slacken the coupling nut at the upper end of the dirty oil inlet pipe, then slacken the bottom coupling nut at the pipe support. This enables the pipe to be swung clear, allowing access to the clean oil discharge pipe below. Now this pipe is slackened and swung aside, giving access to the water outlet pipe, the lowest of the 3 connections, which can now be disconnected and swung aside. Finally, the seal water inlet pipe union is disconnected and the pipe removed. Now slacken the clamp screw on top of the unit and lower the clamp stirrup. Lift clear the dirty oil inlet housing. Then, using the pin spanner provided by the manufacturer, unscrew the inlet pipe in a clockwise direction, this being a left-hand thread. When the inlet pipe becomes free, lift it, and the small O-ring clear of the separator. Remove any deposits and check the condition of the screw thread. If damage or wear is apparent, the part should be replaced. Now the middle housing can be lifted off. And the water connection housing pulled clear. Slacken and lower the frame hood clamp bolts. Then carefully lift the frame cover clear. Tighten the special wrench provided by the manufacturer onto the small lock ring. Then with a copper hammer, free the lock ring in a clockwise direction, as this ring has a left-hand thread. When the ring is free, remove it. Lift clear the water discharge pairing disc, and then the gravity disc. Now the large lock ring can be removed. Locate the tool, specially provided by the manufacturer, into the slots provided in the lock ring. Then hammer the tool in a clockwise direction. This ring also has a left-hand thread. When free, lift the lock ring clear of the bowl assembly. Fit the manufacturer's lifting device, tightening the body of the tool onto the bowl hood in an anti-clockwise direction, then screw down the central lifting eye in a normal clockwise direction. This will ease the bowl hood free, so that when the lifting gear is attached, the hood can easily be lifted clear. Attach the lifting gear and raise the bowl hood. When the hood is clear of the separator, carefully lower it to the floor plates, having first placed a sheet of wood over the plates to prevent damage to the components. Now the top disc is lifted clear and placed on a workbench for further dismantling. To remove the level ring and oil discharge pairing disc, screw the inlet pipe anti-clockwise into the oil discharge pairing disc, which is still held inside the top disc. Protect the top of the inlet pipe with a block of wood and gently knock the pairing disc and level ring out with a hammer. The inlet pipe is then unscrewed and the components set aside for cleaning and inspection. Now lock the special lifting device into the top of the disc stack distributor, and using the lifting gear, withdraw the distributor and disc stack assembly, taking a special care not to damage the lock ring threads in the bowl body or the disc stack itself with the chain hoist. Lower the assembly gently onto the sheet of wood so as to avoid damage and to facilitate cleaning and inspection. Remove the lifting device. To clean the disc stack, Alfa Laval recommend total immersion in a chemical cleaner. If, however, this is not possible, each disc must be carefully and individually cleaned. When removing discs from the disc stack, it is important to make sure that the discs are kept in order. Cleaning in this way should be carried out with a rag, as any abrasion to the disc surface would damage the disc and encourage dirt adhesion. When all the discs have been removed, clean the distributor and inspect it closely for signs of wear or corrosion, especially around the distributing holes in the bottom. After this inspection, and when the discs have been cleaned, the unit can be reassembled, noting the position of the guiding slots and taking care to keep the discs in order. Loosen and unscrew the spindle cap nut in a clockwise direction. On some models, a special tool is required to loosen this cap nut. Lift out the distributing cone. Again, using on some models is required the special tool. Place the cone to one side for inspection and cleaning. Fit the Alfa Laval lifting tool by screwing it clockwise onto the sliding bowl bottom. Then, using the lifting gear, hoist the component clear and lower it gently onto the wooden sheet, taking care not to damage the upper sealing edge or seal ring seating. Remove the 3 bolts from the bottom of the bowl body, using a T-bar and socket. Place the lower part of the bowl body removal tool into position and bolt it down securely. Now screw the upper part of the tool into position and wind down the central lifting screw. Using a bar if necessary. Attach the lifting gear and hoist the bowl body clear of the separator, again lowering it onto the wooden sheet on the floor plates. Undo the lifting gear and remove the lifting tool. In order to carry out further dismantling work, it is necessary for 2 men to carefully invert the bowl body and place one side on a wooden block. Using an Allen key, remove the recessed set bolts from the spring support plate. As these bolts are slackened, allowing the springs beneath to decompress, the plate will rise. When the bolts are out, remove the plate and the springs and put them in a safe place. Remove the Allen bolts from around the edge of the dosing ring. Then fit 2 lifting eyes into the screw holes provided on opposing sides of the ring. Securely fix a suitable lifting sling. Attach the lifting gear and hoist the dosing ring clear. It is sometimes necessary to tension the lifting gear, then tap the center of the bowl, which has been suitably protected, to release the dosing ring before it can be lifted clear. Now fit the eye bolts into the screw threads provided in the operating slide. And lift this clear by hand, placing it bottom downwards on the wooden sheet to allow subsequent inspection of the valve plugs. Remove the operating water pairing disc from the separator, slacken and remove the Allen screws evenly from around the spindle, and lift the pairing disc assembly clear. The sludge seen here is from a particularly dirty heavy fuel. This completes the strip down. In this section, we shall cover cleaning and inspection of the components. The operating water pairing disc and cover must be cleaned carefully, having further disassembled the unit into its component parts. If necessary, steel wool may be used to remove stubborn limescale deposits. Attention should be paid to all orifices and channels in the disc. When the component parts have been cleaned, fit a new sealing ring. Assemble the 3 components, placing the pairing disc correctly into the cover top, then refit the bottom of the cover, and bolt it down. Fit a new joint to the underside of the pairing disc using a little grease or adhesive. Take care to align the holes correctly. The grease and or adhesive will keep the joint in position whilst the complete assembly is inverted. Fit new O-rings to the operating water ports on the upper side of the assembly. After thorough and careful cleaning, an inspection of the operating slide can be made. Check the top sealing surface of the 3 nylon drain valve plugs. The plugs are removed with a small drift by knocking them from underneath the slide. Even if only one is found defective either by abrasion or becoming porous, all 3 must be replaced. The sealing ring should be removed by carefully prizing it out of the groove. New nylon drain plugs are being fitted here using a soft block of wood and a hammer. Refit a new sealing ring to the groove around the operating slide. Then a new sealing ring to the bowl body. New rings should be lightly lubricated before fitting. Examine the sealing surface on the bowl body corresponding to and in contact with the nylon valve plugs during normal operation. Remove any marks or deposits with very fine emery cloth. Turning the bowl on its side, make sure that all the lock ring thread grooves are clean and free from damage. If damage is evident, the thread should be dressed with a fine file or preferably emery cloth. Inspect the areas around the bowl wall pillars between the sludge ports for erosion, even if erosion liners have been fitted. Check the cone inside the bowl body for impact damage or rusting, removing any marks by careful use of a scraper or fine emery cloth, finishing with a polishing cloth. Check all ports throughout the component, carefully ensuring that they're clear. This is a vital operation, as any blocked or even partially blocked operating water ports can prevent correct function of the bowl opening and closing mechanism. The dosing ring should be inspected, especially the inner two surfaces of the ring, which are normally in contact with the operating slide. The side nozzles and bottom nozzles can be checked by using an air line as seen here. The geometry of these holes prevents the use of a thin wire. Check the surfaces of the operating slide normally in contact with the dosing ring for marks or abrasion, and polish if necessary. Inspect the operating slide springs. Any defective, broken or unequal length springs must be replaced. The seal ring on the sliding bowl bottom should be removed. Inspect the sealing edge for abnormal damage. It is possible to rectify damage by careful turning. Check the sliding bowl bottom for signs of corrosion or erosion. Lastly, remove the small O-ring, seen here. Now turning to the bowl hood, inspect the main seal ring and the lower edge of the hood. If the ring is scored or porous, or if the sealing surface is depressed by more than 1 millimeter, despite otherwise good condition, replace it. The ring can be removed, as in this example, by carefully tapping with a hammer and pin punch through the holes in the hood. The smaller seal ring should also be removed. Having removed both seal rings, their grooves must be carefully cleaned. To refit the main ring, ideally a two-man job, first position it correctly by hand, then using a flat piece of wood as protection, carefully hammer the ring evenly into position. Now the smaller seal ring can be replaced. Refit the small O-ring into the sliding bowl bottom. And finally, clean the inside of the frame housing. Check that the operating water flows correctly from the respective ports. Inspect the bowl spindle shaft for impact damage or corrosion, and if required, redress this with an oilstone and polishing paper. Reassembly. Before commencing reassembly, it's wise to destroy all the old O-rings that have been removed. We begin by fitting the water pairing disc assembly. Lower this unit over the vertical shaft, align the water distribution holes, and secure with the said screws. Having lubricated the new seal ring and fitted two diametrically opposite eye bolts into the operating slide, lower this component onto the bowl body. Coat the sliding faces, as seen here, sparingly with molybdenum disulfide grease. Lastly, remove the eye bolts. Screw the eye bolts into the dosing ring and carefully lower the ring onto the operating slide and bowl bottom and gently tap home. Apply a thin film of molybdenum disulfide grease to the screws, fit them by hand, then diametrically tighten them with a torque wrench, having consulted the Alfa Laval handbook for the correct setting. Place the springs into the recesses on the operating slide and align the stamped numbers on the support plate with those on the operating slide and the dosing ring. Tighten the screws successively to compress the springs. Sparingly rub molybdenum disulfide grease onto the spindle shaft. Excessive grease may cause bowl slippage. Turn the bowl the correct way up, fit the lifting tool, then lower the bowl into the machine casing. The bowl will come to rest supported on the vertical shaft by the central screw of the lifting tool. Unwind the central screw to lower the bowl completely, then remove the lifting tool. Apply a thin coating of molybdenum disulfide grease to the bowl nuts and tighten them firmly using a T-bar and socket. Lubricate the sealing ring around the outside of the sliding bowl, fit the special lifting tool, and using the lifting gear, lower the bowl into position. And then remove the lifting tool. Note the position of the locating mark on the distributing cone and align this with the guide lug on the bowl body. Then lower the cone into the sliding bowl bottom, making sure that the recesses on the underside of the cone fit over the guide pins on the bowl body nave. Screw down the spindle cap nut, remembering it has a left-hand thread, and tighten securely. Having cleaned and correctly assembled the disc stack, fit the special lifting tool and lower the stack into position, ensuring correct location by reference to the locating mark on the distributor and the guide lug on the bowl. Ensure that the recesses on the underside of the distributor fit over the guide pins of the distributing cone, and then remove the lifting tool. Now the oil pairing disc seen here, prior to cleaning, is refitted. Note the blockage of the oil channels. And here is the disc after cleaning, an operation sometimes overlooked, showing the oil channels correctly cleared. Inspect the surfaces of the disc. Check the internal threads and the corresponding threads on the oil inlet pipe. Place the pairing disc the correct way round into the top disc. After removing any burrs from the top of the level ring with a fine file, fit a new and lightly lubricated seal ring. By locating the lug on the level ring and the top disc, the ring can be placed in position. Now, using a protection block and hammer, these components can be gently tapped into place. Fit the top disc assembly onto the distributor, ensuring that the bore mark on the disc is facing the locating lug on the bowl body. Having fitted the special lifting tool and lifting gear to the bowl hood, lower it in position, aligning the guide lug with the corresponding recess in the hood. Remove the lifting tool and lifting gear. Coat all the threads and contact surfaces on the lock ring and bowl sparingly with molybdenum disulfide grease. Lift the lock ring into position, locate the lock ring onto the thread of the bowl assembly, and wind down in an anti-clockwise direction. Pressure should be felt as the ring is tightened. If no pressure is felt, extra discs may be fitted to the stack to prevent subsequent machine vibration. Place the special tool over the lock ring and then, using a hammer, bring the two alignment marks together. If the alignment marks cannot be matched to within 25 degrees or are obscured, refer to the maintenance handbook. The sealing ring in the top of the bowl hood should be replaced. Fit new packing to the gravity disc and position it. Details of gravity disc selection appear in the next section. It is now necessary to replace both the small sealing rings to the top water pairing disc. One on the top and one on the bottom. After this operation, reposition the disc. Now fit the small lock ring, tightening it in an anti-clockwise direction using the special tool and a hammer. The threads of the lock ring should be thinly coated with molybdenum disulfide grease prior to reassembly. After replacing the O-ring, position the frame hood and clamp it into place. Rotate the bowl by hand using the worm wheel to establish that there is no internal fouling. Clean and check the O-rings and sealing faces on the connection housings before reassembly. Refit the water outlet housing, the clean oil discharge housing. Insert the oil inlet pipe, having first lubricated the thread, and screw the pipe anti-clockwise into the oil pairing disc using the special pin spanner. Fit the dirty oil inlet housing, swing the clamping stirrup into position, and tighten the clamp screw firmly. Reconnect the water outlet, clean oil discharge, and dirty oil inlet pipes, and tighten them at both ends. Reconnect the seal water pipe and fill the gearbox to the correct level with a recommended lubricant. Finally, refit the revolution counterplate assembly. To recommission, having filled the gearbox, disengage the brake, open the required valves and cocks, then reconnect the power source. This completes the overhaul of the bowl. Gravity disc selection. As a guide to the selection of the correct gravity disc for purification, reference should be made to the appropriate nomogram in the operator's manual. Instructions for clarification will also be found. The diagrams apply to a number of machines, but they all show purified gravity disc selection. Each colored band denotes a different disc. The density of the fuel to be treated should be known and have been corrected to a temperature of 15 degrees centigrade. Draw a vertical line from 98 degrees centigrade on the base of chart A. This is the recommended maximum temperature for the treatment of residual fuels. Now take a line parallel to the diagonal colored lines, starting from the fuel's density at 15 degrees and continuing to the 98 degrees line. From this point, take a horizontal line to the left-hand edge of diagram B. Draw a vertical line from the base of chart B, corresponding to the throughput at which the separator is being operated. Take a line parallel to the colored diagonal lines on diagram B, from the point already located on the left-hand edge until the line intersects the vertical denoting throughput. As the separation temperature is 98 degrees, locate this point on the base of chart C and draw a vertical line. From the intersection on chart B, take a horizontal across to chart C, continuing it until it intersects the separating temperature line. This final point will be located in one of the banded areas. This gives the starting point for determining practically the best-sized gravity disc. Select a disc 2 sizes larger than shown. Fit and run the separator. If the water seal breaks, stop and fit the next smaller sized disc. Fit progressively smaller discs until the seal does not break. This process of selecting the correct size disc will ensure maximum purifying efficiency.